here it is. Cool. Welcome in, everyone. Cool. Now everyone's showing up. Perfect. Welcome in. Welcome back. All right, let's get into it. So I'm going to now share my screen again, and I'm going to go over the announcements. So some of you might have noticed as of last night around 1 or 2 in the morning, all of your homework assignments that you have turned in have been graded. Now, what I mean by graded is I have gone through them all and provided some feedback. Obviously, I wasn't able to look at everything, but so here's kind of how it works. If I give you a 10 out of 10 based off of looking at everything looks right, great work. I don't think that you got anything wrong. If I gave you a 9.5 out of 10, there's just one small thing and I made a comment of it. Okay, hopefully you can all see the comments that are coming through. So I make a comment on the actual homework submission. So it'll either notify you, you can go back, check it. And I think there's a way to respond to people there. If I give you a 9 out of 10, that's just letting you know hey, there's a few corrections just overall on this problem, that problem, a few different things. So if, that at that point, it's hard to kind of go through and explain every single thing in the comment section. So if you want more clarification, show up to office hours with, Alex, Brandon, or me, and then you can pull up the homework assignment and we can go through it together and just talk about it. But as you can see, obviously, I'm not giving anyone an 80% or a 70% or a failing grade, okay? Because the reason why I'm doing this, I know originally I said that I would just give everyone full credit as long as they turn it in, but I think it's also a little bit more useful to just see, so that way when you go back through your assignments, right, and you see, oh, okay, I'm missing a point here or a 0.5, right? It's kind of like a grading rubric so that you can kind of make a mental note, go back and check it and be like, oh, okay, let me go see where I went wrong, right? But as far as I'm concerned, if you're turning in work and you're wanting it to be graded, I think that's a good system to follow, just so that way, that way you can be like, okay, I know that this assignment, I got a 10 out of 10. I don't have to really go back and check it because that means, theoretically speaking, I'm good to go, right? So that's how I'm kind of doing things. And yeah, so all of the homework assignments have been graded. Now, the homework assignment that was due over the weekend, I finally got up to making the assignment tab for that last night. So I saw that some of you have already submitted it. That's great. It is due by this Saturday at midnight. So from here on out, I'm going to make sure that all of those assignments from Monday till now, all of those assignments are going to be open, ready to go. Office hours for me. So I figured this would be best. 10 to 15 minutes before the start of class, I'm going to try and be on here. So around 8:45 to 8:50. Every single morning, I'll be here about 25 minutes early. That way, 20 to 25 minutes early. And if anyone wants to talk to me, ask me questions, I'll be here. And if you just want to come hang out with me until then and just, chill and chat, that's totally cool too. So I will plan to be here on around 8:45 every single morning before lecture starts. Now, office hours after prep, okay? That is where Alex and Brandon are going to talk to you real quick. Do you want to kind of go over that a little bit?
Yeah, I'll go first. So what's up, everybody? I'm now more active. I'm finally at home. I was away, but it's time now for if y'all ever have any questions about any of the assignments, any questions about Berkeley. These office hours can be whatever you want them to be. I'm making time for y'all just to make sure that that you can at least be heard if you have any questions. But yeah, Monday through Friday, 6 p.m. They will go on probably as long as till Brandon will be there. But for sure, we'll be starting at 6 o'clock Monday through Friday. So I hope to see y'all there. And we're going to be doing the homework beforehand. Everything that Zach gives you, we're going to be doing the same thing. So we'll be ready to go with any questions. And then during the lecture, hopefully I'll be here. So if you have any questions in the chat or just in general, we can answer them for you so Zach can continue lecturing. But yeah, that's just an update on me. Yeah, and I hope to see y'all at office hours. Should be fun.
What are the times again, sorry?
6 p.m. till whenever we end, basically.
Perfect. Yeah. So the link for that will not be the same link as mine. So that will be a different link. So Alex, you can either send that in the chat now, or I think he will make sure to send that link through the announcements. So check your email or check the announcements on B courses a little bit later today. I don't know if Brandon's here or not, but if Brandon is here, Brandon can either talk about his office hours. If not, that's okay. I believe Brandon will either be helping out with Alex, or I think Brandon's going to try and go 1 hour later after Alex or something like that. But again, we'll get more info on that soon. But yeah, tentatively speaking, Monday through Friday, Alex and Brandon will be there to help you all out. And then in the mornings, I'll be here to help you out too. So whatever works best for you. If you're a morning person, I'll be here. If you need some time to just, get through the day, go get help from Alex and Brandon. They are both absolutely wonderful people. Fun fact, Alex was also my one of my prep leaders when I was in prep back in 2019, and he's absolutely wonderful. And Brandon is also absolutely wonderful. So you're going to get
basically saying I'm old. So
no, of course not. I mean, but at the end of the day, I guess you are a senior now, so it's just crazy. But yeah, no. So they're great. They're going to be awesome. So go give them some love and hang out and chat. Now, with that, let's check the chat. Okay, yeah. Let's talk about assignments real quick. Late assignments, all that stuff. Yes. So I tried to push back the deadlines for every single. I tried to push back the deadlines for every single assignment. Some of them, the website's being weird. By the end of today, tomorrow, I'm going to try and have all those assignment windows open until Saturday. Okay. And I'm going to try and give all of you a chance to turn it in, because at the end of the day, right, I don't care that you turn it in late. I just care that you turn it in and I give you the feedback, right? If you're putting in the work, I want to put in the work too, to help you and be like, hey, you're on the right track. Hey, here's where you could improve, right? So that's all I care about with the homework. And with that, I'm dealing with like the website issues, because this is my first time being on the other side of B courses on Canvas, right? The teacher side. It's actually really cool. I also want to talk about a few things too after that. But yeah, as far as late homework assignments go, I know some of you emailed me just your late homework assignment, said, hey, I'm not able to turn this in. Here's my homework. And then I said, awesome, cool. I tried to respond to you. I made a note of that in the actual grade book. So your grade should reflect that. And you should hopefully have gotten that feedback too. So if for whatever reason you're still having problems after today or tomorrow submitting late homework, shoot me an email with the PDF. I'll look it over. I'll give you some feedback right then and there, and that'll be good to go. But yeah, again, late homework assignments, totally cool with me. It's really not a big deal. But again, when you get to your professors in Berkeley for your first semesters and so on and so forth, just be mindful that they are going to be much, much less lenient. I mean, obviously coming out of COVID, there might be some leniency, but for the most part, when it's back, I think when it's back in person, it's going to change drastically. So just keep in mind that. One other question, actually, okay, let's stay on topic real quick of the B Courses website. I just wanted to let everyone know this, and because I didn't know this until being on the other side of it. When you are accessing the B Courses webpage for each of your individual classes, your professor can see everything. And what I mean by that, they can see how much time you've spent on their website. They can see how many times you've logged in on their website. They can see the last time that you've logged in on your website. They can see even down to like which individual link, right? Are you spending time on modules? Are you spending time on assignments? Have you seen this file yet? Have you seen that file yet? And so it even keeps track of all the time, all of that. Now, am I saying this to scare you? Yes and no. Did I find it fascinating? Yes, because I didn't realize that B Courses has all that information. Did I like look at who has not shown up once to B Courses and who has never submitted an assignment? No. Okay. But I wanted to let you know, your professors and your teachers, they can. So just keep in mind, right? If for whatever reason, obviously things come up, but definitely, if you're putting in the work, great. If you're not, just know when your professors see it, your professors can see it, right? And that's all. So I just wanted to share that with everyone, because I didn't even know that, right? And I've been here for going on 3 years now. So just know your professors are always watching. It's like Mike Wazowski, I'm always watching you. Sorry. Yes. Anyways, so just want to let you all know that. Anyways, YouTube is up. All the videos are posted. Modules are up. Assignments should all be graded. I'm going to work on changing those deadlines. Awesome. Am I forgetting? Oh, all right, cool. I'm going to stop sharing now. All right, in the chat real quick, I want everyone to let me know. I was trying to make a poll. How is the homework going? Is it too much? Is it too little? Are you spending too much of your time? Are you not even doing the homework? That's okay too. I just need to know where everyone's at so I can try and figure out, you know, should we try and like even condense this homework a little bit more? Should we try and figure out something else? Go ahead and just type in the chat if you're feeling overwhelmed, underwhelmed, or if you think everything's going good. I see Leslie's giving me a thumbs up. It's a good amount, not too stressful. It's a good amount. Okay, perfect. Feeling good, just right. Awesome. Good, good. It's good. It's good. I'm waiting for that one. It's horrible. I'm kidding. So that's cool. I just wanted to do a little check-in, right? Because I know it's been 4 or 5 days. And so yeah, you know, if you're having issues with the homework or if you're having connectivity issues, anything like that, that's all good. Just again, this homework is not to be graded to give you a grade in the class. This homework is to be graded. Yeah, this assignment is just to be graded to give you guys feedback, right? So if you are just strapped on time and you feel, because I know there's definitely some people who just have not submitted a single assignment yet, whether that's connectivity issues or you just haven't gotten to it, that's okay, right? I just want you to put in the work now so that way when you get to school and you get to your first semester, things will go a lot smoother, right? So think of this as just a warm up, you know, a few weeks left to kind of study, prepare, get ready for Berkeley math, right? Because Berkeley math is, I know we're going over a lot here. Berkeley math is a whole new level, right? And I think Alex and Brandon can both attest to that. I have one person messaged me privately and said that factoring worksheet was evil. Yes, I know it was. I take a great pride in that. I'm kidding. So I was thoroughly impressed with those of you who did the factoring worksheet. Because I know how awful that was, right? Because my first day of calculus, I had to do it too. Yeah, super impressed. I'm just seriously like, great job. Even if you weren't able to attempt all the problems, great job, because it's a lot. I know it was a lot. And so hopefully you can see that all the homework assignments since then have been way less. So yeah, factoring worksheet, great job. As far as everything else goes, the homework solutions, okay, we're going to be working on that. So I'm either going to reach out to a few of you that I was very impressed with your work, and I'm going to either see if I can use your homework to either post as the solution. I'll blur out your name and or delete your name, and I can use that, right? Because I mean, your handwriting is better than mine. So if you get an email from me, don't worry. It's just me asking you like, hey, can I use this? Because this is absolutely amazing. Or me, Alex, and Brandon, okay, we're going to start working on getting these homework solutions out to you to provide even more feedback, right? So stay tuned for that. But again, if you're struggling with time and time is the reason why you're not able to submit these homework assignments, I'll make a deal with you. Okay. I'd rather you turn in something than nothing. I'd rather you do one of the, like if I assign 4 problems, if you're doing one of them or 2 of them, okay, just so I can give you that feedback, I'm okay with that too. So, and I'm not going to give you, if you make a note of it and you just say, I'm only attempting these 2 problems for the interest of time, right? I'm not going to give you like a 9 or 9.5. I'll grade you based on how you tell me to grade you, if that makes sense. If you say, here, I submitted all of the problems, go ahead and give me a grade for all of them, I'll do that too. But yeah, again, if you can get it in, great. If not, no worries. So it is 9:30. Hopefully everyone was able to, sorry, I know I'm talking fast here. We have just so much material to cover today, but I'm going to go over it. The lecture is being recorded and it will be posted to YouTube. Go ahead and check it out after as well. I'm sharing my screen now. The whiteboard, here we go. We are going over sections 2.2 and 2.3 today. And this is the definition of limit. This is where calculus gets started. This is the fundamental, this is the basis for your basic calculus courses, and then from infinity to beyond. Speaking of infinity, that's where we're going to start today. We're talking about limits. So I need a quick coffee break. Anyways, yeah, we are talking about limits today. All right. And I just want to give you a basic example. We know that, let's talk about the graph y equals x squared again. Y equals x squared. We're talking about limits. So I'm going to draw it. just pretend that that touches the origin. Again, I understand that that might get confusing. It's just my handwriting. So this is technically the origin right here with that 1 point. As x goes on infinitely to the right, all right, we were talking about domain and range. As x goes on to infinity, right, what happens to the y value on the right side? Can someone just tell me real quick? In the chat or in person.
Infinitely bigger.
Wait, what did you say?
Yeah. Okay, perfect. It gets infinitely bigger. And in other words, as our x values get larger and larger, right? Let's say we say x is equal to 1 billion. So, or 1 gazillion, 10 times whatever to the 26th, okay? And we plug that in for y. Well, 10 to the 26th squared is a insanely large number, right? That's our y value. So our y value, right? Our y value is going to infinity, right? So if we plug in infinity for x, we see that our y value is going off to infinity. That should make sense to everybody. Another way we can write this is the limit, right? Another way we can rewrite exactly what I just explained is I can say the limit as x approaches infinity, okay, of f of x, right? In this case, I know I said y. I'm going to just rewrite this as f of x, okay? The limit as x approaches infinity of f of x is equal to infinity, right? We said as x is approaching infinity to the right, it is going way like to the sky and beyond, outer space, the far reaches of space, beyond space, if that's even possible, right? I mean, it goes on forever. That is all I mean by limits, okay? So if you can kind of keep that understanding in the back of your head, that's perfect. All right, I'm gonna create a new tab here. I'm just gonna keep on going. So with that, let's talk about limits. Let's talk about special types of limits, okay? So, okay, we can also write it as this, right? This is the graph of x squared again, okay? Y equals x squared, right? This is the origin right here. This is the point 1, 1, right? So this is 1, 1 right here, okay? So I have a question for someone. The limit as x approaches 1, okay, of x squared or f of x, right? Can someone tell me what that is? As x approaches 1, what is the limit? 1, right? Hopefully everyone can see where I'm getting that. All I'm saying is this, okay? X is approaching 1, right? So this is the point, oh, sorry. I should redraw that. This is the point 1, 1 right here, right? Right here. That's the point 1, 1. So all I'm saying is as x approaches 1, okay, I'm asking what is that y value? Well, that y value is 1. Cool. Everyone's on the same page. That's awesome. Thank you for all that responses. That makes total sense to everyone, hopefully. Cool. Now, let's talk about the graph 1 over x, okay? I'm not going to draw it out just yet. I want to talk about it. 1 divided by x, okay? We have f of x is equal to 1 over x. All right, I'm just going to start plugging in some numbers, all right? What if x equals 1, okay? We get the point 1, 1, right? What if x equals 2? We get the point 2, 1/2. In this case, I'm going to write 0.5, right? Because I think decimals will help everyone understand this a little bit better, okay? What happens if we plug in, let's say 10, right? We have the point 10, now it's 1/10, right? 10, 0.1. Hopefully everyone's seen this, right? Now, what happens if x is 100, right? We now plug in 100. We get that the y value, right? 1 over 100, well, that's just 0.01. Does everyone see that? So what happens as x is getting, so these are, I'm just plugging in values for x, right? What happens as x is getting larger, larger, and larger, right? 1, 2, 10, you can see that our y value is getting smaller and smaller, right? 0.1, that's 1/10, that's pretty small. 0.01, that's 10 times as small, right? So let's think of it this way, okay? What happens now if I have 1 over, let's say 1 million, okay? Okay, that's going to give me something like 1 million, comma, oh gosh, someone work that out for me so I don't make a mistake. Is that that's 0.00, is that 1, 2, 3, 4, 5, 6? Is that 1 times 10 to the negative 6? I'm going to assume that's 1 times 10 to the negative 6. If it's wrong, That's just correct me, but I'm just doing mental math here really quick. I believe that's, so you can see that number is like 0.00000001, right? I mean, it's getting smaller and smaller. So what happens as this is getting smaller and smaller? Well, you can see that this, like this is getting closer and closer to just the number 0, right? So if you can kind of envision this in your head, right? The larger that x gets in the denominator, right? The larger that x value gets, the closer and closer we get to 0. Now, here's a very, very important thing that hopefully you can conceptually grasp based on all of this that we're going over and explaining, okay? If x is infinity, right? But x can never equal infinity. So we say as x approaches infinity, right? Now it becomes 1 over infinity. Remember, if infinity goes on and on, or if infinity is an infinitely large number, okay, what is our intuition leading us to think? What would our y value be if x is infinitely large? What? Yes. All right. Kamani is saying 0, right? Does everyone see sort of how that makes sense, right? 0. Now, if we look at our 1 over x graph, okay, let me just graph this real quick. It's going to look something like this, right? And you'll notice really quick here, okay? If this goes on to infinity, you can see how this is getting really close to 0, right? Technically, yeah, I get that it does this too, right? So it does something like this. But now you can see visually, right? It goes on to 0. But at the same time too, okay, what happens if we do the flip side, right? What happens if we start plugging in really, really small numbers, right? What happens if we plug in 0.001 here, okay? Now that's 1 over 0.001, which is the same as saying, so if you divide that in your calculator, I'll do it really fast just so everyone can see that number, okay? 1 divided by 0.001, that's 1,000, right? So you can see as x approaches 0, right? As x approaches a very, very small number, so we say 0, okay? We can see that the number actually becomes infinitesimally big, right? And we can see that through the graph of 1 over x, right? What happens as x approaches 0 right here? Well, it shoots off into infinity, okay? See that? I mean, it just goes on to infinity, right? We will never reach it. It just goes straight up. So now you're probably saying, wait a second, Zach, that's positive infinity, right? This is positive infinity. What about negative infinity? Great question. I'm so glad someone asked that. I'm kidding. I asked myself. Haha. That leads me into our next segment. So takeaways. Okay, 1 over infinity. The limit as x approaches infinity, right? So the limit of 1 over infinity. I want you to start thinking of that as 0. Okay. 1 over 0. I want you to start thinking of that as infinity. Okay. All right, let's go ahead and delete this real quick. 9:35, wow. Okay, I was talking fast. I know it's hard to keep up, but hopefully you can. Is this when the distance between the line and the axis, half each time and never reaches 0? If I understand your question correctly, this is basically sort of, right? You're talking about steps like leading up to it, sort of, kind of, yeah. All we're doing is we're plugging in numbers, right? And we're saying, okay, as we go farther and farther and farther along, right, we see that we're approaching 0 here. And as we go, you know, as we get closer and closer to 0, right, making our x value smaller and smaller, right, we can see that number is shooting, it's skyrocketing into the sky, taking us to infinity, okay? Let's go ahead and draw that graph again of 1 over x, all right? We said it looks something like this. And I said, as x approaches 0, right? So let me draw this again. I said, as x approaches 0, okay? I said that the limit as x approaches 0 of 1 over 0, right? So we plug in 0. That's how we take the limit. We plug in 0. 1 over 0 is infinity. Okay, I said it's equal to infinity, right? Positive infinity. Now you can see right here, wait a minute, okay, this is positive infinity. What about the other half of the graph? What about this down here, right? Isn't that negative infinity? Doesn't that also go to 0? Where are you getting these numbers, Zach? Great question. Now we're talking about one-sided limits, okay? So I'm going to write that over here, okay? One-sided limits. One-sided limits. One-sided limits, okay? Basically, you can denote it as so, okay? the limit as x approaches infinity, or as x approaches 0 from the left, okay? So that negative sign on top, that means I'm approaching from the left, okay? And I can also take the limit as x approaches 0 from the right, and I'm gonna denote that with a positive sign, okay? I see a little bit of lag, hopefully that's coming through. So I can take the limit coming in from the left, and I can take the limit coming in from the right. Hopefully that makes sense to everybody. I'm gonna try and explain it right now graphically. Let's focus on the limit as x approaches 0 from the left. So we're coming in from the left side. In other words, the left side of the graph is this right here. Does everyone see that? So I'm following along. Okay, I'm plugging in x values. All of a sudden, I'm getting closer and closer and closer to 0 from the left side, right? Oh my gosh, this is going on to negative infinity, right? So all I said was I'm plugging in negative values, right? Because on the left side, those are negative values. On the right side, those are positive values, right? An easy way to do this, set up a table. One of your homework assignments is going to be like, or one of your homework problems is going to be very similar to this, okay? It's going to ask you to approach or approximate it from the left or from the right. So basically, how do we approach this from the left? Okay, so I'm going to say my x value is negative 0.1. Okay, I need my calculator for this. Okay, 1 over negative 0.1, that is simply negative 10, right? I'm now going to pick another number. I'm going to say, all right, let's get even closer to 0. Let's plug in negative 0.01, okay? And that's going to give me something, that's going to give me 100. That's going to give me negative 100, right? So I'm plugging in negative values. Sorry, that's negative 0.01. So now let's say, okay, I'm getting even closer to 0, right? So now I'm just going to step it up a little bit. Let's say I plug in the value negative 0.000001. Okay, so 4 zeros. I'm going to quickly calculate that out. Okay, that gives me negative 100,000. Okay, so I can see as I'm getting closer and closer to 0, right? I could even do negative 0.1 times 10 to the negative times 10 to the negative 30. Okay, I'm going to get a massive number. I'm not going to write it out, but I think you see where I'm going with this, right? You set up a table, you start approaching 0 from the left side, right? So you're using the negative numbers, right? Because to the left of 0, those are all negative numbers, right? But I'm plugging in negative 0 value, right? Getting closer and closer to 0. You can see this is going all the way to negative infinity, right? So as we approach the limit as 0, right? As x approaches 0 from the left, we get negative infinity. Our intuition tells us that's correct because we can see this is going all the way to negative infinity. Now, likewise, on the opposite side of things, right? We have the limit as x approaches 0 from the right. Same process, right? Now, instead of negative signs, I'm going to plug in positive values, right? See how I did that? And see how these become positive values. All I did was change the negative sign. It's cool because this graph is symmetrical in the negative yx line. So this is our x value, this is our y value, right? Now you can see, okay, as we're coming in from the right side now, right? We can see that this is taking us from the right side as we get closer to 0. That's taking us all the way to positive infinity, okay? So this is positive infinity, and this would be, oh gosh, sorry, that's positive infinity, and this would be negative infinity. Okay, so we can take limits from the left side and the right side. All right, a little bit more things. All right, we are doing okay on time. I'm going to pick up the pace a little bit faster. Now you can see why I said read ahead beforehand, so that way, even if you might not understand it exactly, when we get to lectures, they are clear and concise, and anything that didn't make sense hopefully is making sense now. So we just talked about one-sided limits, intuition limits, cool. Let's talk about asymptotes real quick. Asymptotes, I don't know how, is the P silent or not? Fight it out in the chat. Anyways, let's say we have a simple x times x plus 1, okay, divided by x plus 1, okay? This is the graph y equals. So all I did was factor this out. This would have been x squared plus x over x plus 1, right? Obviously, we can see these cancel out. But at the same time, that means that we're going to have an asymptote right there. Why? Because x plus 1, right, going back to our domain, we said x plus 1 cannot equal 0, right? Because if the denominator is 0, then that'll mess us up. That's undefined, right? But I want you to start thinking when it's 0, technically it's infinity, right? 1 divided by 0, oh, that kind of takes us to infinity. So I want you to start kind of thinking in that mindset, okay? But we get that x cannot equal -1, right? X cannot equal -1. Now, you're probably saying, now, wait a second, Zach. Just like we cancel these out, okay? And we're left with y equals x. You're right, okay? Let me graph that right here. Y equals x, okay? But we said x cannot equal -1. I don't understand what's going on. Okay, so actually in this case, right, we're going to have a hole, okay? So that hole is going to be right here at x equals 1, okay? Hopefully can everyone see that? So this would be my x, y, oh, sorry, that's wrong. This would be my x, and this would be my y, okay? So x, y, okay? Hopefully everyone can see that. This is at x equals, no, sorry, okay, yeah, I caught it, all right, -1, I apologize. I was correct the first time, okay? There's a hole right here at x equals -1, okay? So you'll see it, there's just a hole around it. That basically means that doesn't exist, right? Because we canceled it out, even though we have the graph y equals x, okay? We canceled out that x cannot equal -1. All right, our domain still holds true in this situation. Now, let's take the limit, right? The limit as x approaches, okay, -1. Let's go back to our original graph. We have y is equal to x times x plus 1 over x plus 1. I think I'm seeing something here. Just give me 1 second. Maybe I drew this graph wrong. Maybe I didn't. I don't think I did. Yes, I did. This should be up. Sorry, forgive me. The y axis. I see my mistake now. Again, I apologize. Oh my gosh. Okay, my graph drawing skills are not on point today. XY axis, here it is. Okay, it's up here. This is the point x equals -1. Now it makes sense. Now things should start to click a little bit better. Cool. All right, -1, -1. All right, the limit as x approaches -1, right? Remember, this is 1 over 0, right? So we're saying, wait a second, what's that limit? Well, we cancel these out. Now we have y equals x, like we said, okay? The limit as x approaches -1, right? What is that? Plug in -1 for this equation right here. What do we get? Say it real quick in the chat. It's just -1. Cool. All right. So I'm getting -1 from people, right? Does everyone see that? So yes, we have a hole here, okay? But this hole is at the point -1, right? So if we were to take the limit approaching from the left side and approaching from the right side as x approaches -1, okay, we will get the y value is -1. So that checks out. Cool. I'm going to keep moving forward. What else? That's just about everything that I wanted to cover in section 2.2, okay? One-sided limits, infinite limits, right? 1 over 0, 1 over infinity, right? Those are reciprocals of each other. 1 over 0, that equals infinity. 1 over infinity, that equals 0. Hopefully that makes sense. But yeah, okay, cool. We actually are making really, really great time. I'm now going to keep leading forward into 2.3, calculating limits using the limit laws. Oh, one more thing, okay? This will show up in your homework assignments. Let's say we have a graph like this, okay? And it does something like that, okay? You can also have piecewise functions. What I mean by that is this is a different graph, okay? But you can have x is greater than, you can have something that looks like this. We've seen piecewise functions before, right? Y equals x squared for x is greater than 0, right? And we also have the graph greater than or equal to 0. And then we also have y is equal to 2x for x is less than 0, right? So actually, let me go ahead and graph that real quick. That would look something like this, okay? So this is a piecewise function. You'll see it denoted like so. I'm going to draw this graph, okay? Y equals x squared from x is greater than or equal to 0. That means it's going to go like that, okay? Y is equal to 2x when x is less than 0, okay? So that's going to give us a positive 2x. It's going to look something like this, I believe, okay, with a slope of 2, right? Slope 2. So everyone can see those are two different functions, right? But we graphed them as one because there is that that notation that we can follow, right? So you'll see this will come up a lot, especially with heavy side functions. I'm not going to talk about it now. You'll get to it in multivariable calculus, but for the interest of time, okay, you can see how both of these, right, the limit as x approaches 0, okay, from the left side, right, and the limit as x approaches 0 from the right side, right, we can both see that we're ending with, we're going to approach 0 on both sides, right? Hopefully everyone can see that. We're approaching 0 from both sides, right? If you plug in 0 to this equation, right, from the left side, or this is coming from the right side, so 0 right, okay, that is equal to 0, right? If you plug in 0 coming from the left side, right, 2 times 0, that's 0. So 0 on the left side, that's equal to 0. What does that tell us? That means that the limit exists, okay? The limit exists. All right, same thing goes for holes, okay? Let's say this was a hole here, okay? And we had something that looked like this. Oops, oh, now we have nothing. All right, going back here. Let's say this was a hole, okay? It would still approach 0, right? It's still approaching that hole, and that hole is at x equals 0, okay? That's if we have, yeah. Okay, so hopefully that makes sense. Vertical asymptotes, let me quickly go over that because I said I would. All right, we talked about holes, right? If you cancel something on the top and something on the bottom, right? X cannot equal 0, right? Well, we get the graph y is equal to 1, right? But in this case, so if we have y equals x over x, okay, x cannot equal 0. So we get the line y equals 1, right? But we have a hole at x equals 0, right? Something like that. So that's a hole. Now, vertical asymptotes, okay, as simple as this, okay, the graph 1 over x, right? We've already seen it. We've already been talking about it today. It does something like this, right? In the denominator, right, we said it cannot equal 0. So x cannot equal 0. So we have a vertical asymptote, VA, right, for abbreviation, at, I'm going to put the at symbol, okay, at x equals 0. That's it. That's all. And hopefully that makes sense to you, right? And you can see likewise the negative, right? So we have that vertical asymptote that kind of is like a line that does that, okay? I'm going over that super quick. Anyways, okay, that's all I wanted to talk about for limits. Oh, one more thing, okay? Let's say we have a graph like this, okay? I'm going to put a dot there. Let's say we have a graph like this. I'm going to put a hole there, okay? The limit. Does the limit exist as x is approaching from the left? Okay, so think of this. These are two different graphs. Does the limit exist as x is approaching from the left? Yes or no? I'll call this +1. I'll call this -1. Okay, for the y values. Does it exist? Yes or no? Thumbs up, thumbs down. It'll be 1, right? Yes. Okay, so we can see right here the limit as x approaches. Let's call this y value. Yeah, let's call this 0, right? The limit as x approaches 0 from the left. From the left, that is equal to +1. Okay. What about as we're approaching from the right? The limit as x is approaching 0 from the right. Positive sign now, right? I see people are saying -1. Do we agree or disagree, class? Agree, disagree, maybe. Is Brian the only response? Sorry, say that.
Isn't it cannot equal -1 or something?
So, you know, I want to, so I'm getting people are saying yes, right? Hopefully everyone's on the same page. Yeah, technically, all right, there's that hole there, right? Yeah, there's a hole. So we're like, well, there's a hole, okay. Technically speaking, okay, we can approach that hole, right? We can approach that hole at like -1. In your book, I believe that's how they teach it to you. In other words, it's a little ambiguous, right? Some people like to argue, no, that doesn't exist. Yes, it does. For the sake of teaching you calculus, now keep in mind, this isn't super important, right? But for some of your homework problems, I believe, does everyone else agree with me that this would be -1 if we're approaching 0 from the right? Just say yes or no in the chat. Yeah, okay. So yep. For those of us that have seen calculus before, does it exist? No. Can we calculate, right? Remember, as I'm saying, as it approaches 0, right? X cannot equal 0, right? But it can approach 0. So that approximation, right? That approach we can calculate. And that's where I get -1 from, right? Now, I have a question. Does the limit as x approaches 0 now, okay, does this limit exist? Not from left or right, but as x approaches 0, does it exist? Cool. People are responding in the chat. The answer is no. Let me try and explain this really quickly, and then I'll keep moving forward here, okay? We have, we're coming in from the left here. We're coming in from the right. as you can see, these are two different values, okay? We have +1 up here, we have -1 down here, okay? If the limits, as they're approaching from the left and the right side, if they do not approach the same number, okay? If they are not approaching the same number, that limit does not exist, okay? Can we approximate it from the left and the right side? Of course we can, right? I just showed you how we can, right? Because remember, we can't ever get to that point, but we can get like infinitesimally close. I know it's conceptually weird to think about, but right, it kind of makes sense. So, but if they don't equal each other, and you're just asked to find the limit as x approaches 0, it does not exist. Okay, this does not exist, and you'll see D and E a lot. So on your homework, just put D and E. It's 9:52. I'm going to keep going, but yeah, question really fast. Go for it.
Does it have to have like the minus and the positive thing in order to exist?
So these minus and these positives here, this is denoting this is denoting orientation, right? Minus means coming from the left, positive means coming from the right. Okay, so in order for this limit to exist, right, the left side and the right side have to equal each other. I showed you how to approximate the left and the right side, right, of a limit in the previous example. So go back through and watch that YouTube. I'll post the YouTube today, and go back, watch that, and hopefully you can kind of see how to approximate the left and the right and see if they equal each other. Okay, but yeah, so that's all that means. Okay. Now, I think we just covered just about everything. Okay, so back to that original graph, right? It does something like that. Yeah, we said this limit does exist, right? Because even though technically, right, does the function exist? It's kind of iffy to explain, but piecewise functions, yes. Okay, this exists because they both approach the same point. Okay, I'm going to erase that. Sorry, I know I'm talking really fast. As you can see, we have a lot to cover, and we're only going through chapter 3.9. Your calculus course is going to chapters 6. So we're covering about 2 chapters a day. You'll most likely end up covering 3 to 4 chapters a week. So we're a little bit ahead of the normal pace, right? But this is still pretty accurate to the pace that you're going to see when you get to Berkeley Math. So try and keep up with me if you can. It's okay if you can't. YouTube link will be posted. Office hours, we're super helpful. I'll be here every morning, 20 minutes before. So come up, say hi to all of us, because we are here and we're here to help you. Peace. Okay. Calculating the limits using the limit laws. All right. I'm going to post this super fast. I'm going to post the picture of, yes, this looks right. Share this. Okay. Everyone copy this down as fast as you possibly can. Let's test your handwriting skills. I'm going to time it. You have a minute and a half. 3, 2, 1, go.
Okay, all of them.
What's that? Yeah,
all of them
get all of them. Yeah, just copy them down and I'll try and explain them in just a second. Yeah, these are our limit laws, okay? They're very similar to our addition and subtraction laws and multiplication division laws that we're accustomed to seeing. They're almost very similar, if not the exact same. It's just, it's just for notation purposes, and you actually have a homework assignment that deals with this. Okay, once people start copying this down and they have it copied, go ahead and just type in the chat, good to go. Once I see enough good to goes, I'm gonna start moving on unless someone starts yelling at me, oh my gosh, don't go on. Or if you're joining us for the YouTube and you're watching this YouTube video right now that is currently not posted, but will be posted, so it's kind of paradoxical in nature, but you can go ahead and pause the video and you can start and resume it whenever you would like. Cool. I see one person screenshot it, boom. I think Brian just broke the matrix and just figured out a way to make this super. Oh, one more thing. Some of you are turning in your homework assignments just copying off the PDF. That's fine. That doesn't bother me too much. Some of your professors might not like that as much. They might like hard, concrete, on paper answers. But again, I don't care. I just care that you're turning in work and I'm providing that feedback for you, right? All right. Stephanie is the first one to have said that she has got it. Who's going to come in second place? Sebastian is second. Kamani is third. Annie is fourth. We have 4 people that got it. Boom. Alexandre is done. This is fun. Who got the gold? Oh, that's a great question. Oh yeah, who's watching the Olympics, by the way? I'm watching the Olympics. It is so cool. Okay, I thought it was really cool. They added skateboarding to the Olympics this year. I love that. I'm not like a hardcore skateboarder, but I love snowboarding, and I have a electric skateboard that I use around Berkeley campus. So on Berkeley campus, that's another thing too. Yeah, come to office hours like Alex said, and we can just talk about life. But I have a boosted board, and oh my gosh, that thing gets me everywhere around campus. Highly recommend if you're a skater and you're looking for something transportable. You can also take it with you into class, which is awesome because if you leave your bike outside, even for an hour, there's a good chance that it'll get ripped off. It's Berkeley. But yeah, okay. People are starting to say they're ready. I'm going to go ahead and stop sharing this. If you need to, take a picture of it. If not, I'm going to go over it in more detail. It is also page 95 in your textbook. It is page 95 in your textbook, okay? So go ahead and check out page 95 in your textbook when you have more time. All right, we have 15 minutes left, 15, 16, 17, 18. We have 18 minutes left. I'm going to use all 18 of them. Little side note before we get going. Tomorrow, Tuesday, Wednesday, Thursday, Friday, your professional development on one of those days, depending on which group you are, is going to be the improv class, okay? Guess who's teaching it? That's right, it's me. Yeah, no, I've been in improv for numerous years. My sister actually played professional improv. She was 2 grades above me. She played professionally on the comedy sports team for Sacramento. So that is really cool. I almost auditioned for the one in LA. So I know this is a total side note. I almost auditioned for this one in LA, but obviously I went to Berkeley, so that didn't work out. But yes, I'm going to be teaching the improv classes for the next, from 1 to 2 for your professional development, whatever day you have me. Totally show up. It's going to be a complete blast. Yes, go Bears. Okay, so if you're like, why is this guy so energetic in the mornings? A, because I have coffee. B, because I've done improv for so many years and also theater. So I'm a huge theater geek. But again, it's going to be tons of fun. Expect an email from me later today. All right, I'm breathing. Prep movie star. You know what? Yeah, no, seriously, I could be, right? Also, fun fact, I'm not going to talk about it anymore today, but there is someone in my family that is somewhat famous, and you might know him. So anyways, let's see. Can someone figure out who I am related to that might be famous? You might know of him, actually. So go ahead and try and see if you can figure that out. Obviously not now, but later on. Okay, I totally just wasted 2 minutes, but I think those 2 minutes were worth wasting. Okay, I am now sharing my screen. Hopefully you were able to copy that down. I probably could have left that up. I apologize. Oh, well. Cool. All right, we have limit laws. All right, the limit, I'm gonna just do this really quick. The limit of f of x, right, as x approaches a, where a is a number, okay? A can be any number. Michael Douglas. No, it's not Michael Douglas. That's a good guess, though. I'll give you a hint. TikTok. That's all I'm going to say. All right. Let's say this is equal to 5. Okay. We just found the limit. It's 5. Okay. Now let's say the limit of g of x. Okay. A different function. G of x. Let's say this is equal to 3. Right. The limit. Sorry, that is totally horrible notation. I'm going to put the limit of g of x as g approaches. Is it a different number? No. As it approaches the same. Frederick Douglass. Maybe, I don't know. That's like a couple hundred years. Okay, let's say that equals 3. Okay, so f of x, the limit is 5. G of x, the limit is 3. Okay, running through these really quick. Okay, the limit as x approaches a, right, of f of x plus f of g, okay, or plus g of x, okay. The limit of f of x plus g of x, that's literally just 5 plus 3. Okay, you can see where I'm going with this. I'm going to do a few more of them. Okay, f of x minus g of x. Okay, I'm not using the correct notation just for the interest of time. Not f of g, I'm so sorry. F of x minus g of x, okay? That is equal to 5 minus 3, okay? If it was f of x over g of x, okay, this is the one special notation that you kind of have to look out for. F of x over g of x, okay? The limit as x approaches a of f of x over g of x. Okay, obviously you can see that is 5/3. What is the one special case where we cannot apply this rule? Hopefully you can think about it. Think about domain. Okay, when can we not use this rule? We cannot use this rule when the limit as g of x, or the limit as g approaches a of g of x, we cannot use this rule, okay, when this is equal to 0, right? So you can see how f of x over g of x, all right, if g of x is equal to 0, now it's undefined, okay? So we can use this limit rule, this limit, you know, basically 5 divided by 3. We can use this so long as the limit as x approaches a of g of x does not equal 0. Hopefully that makes sense to everybody. I'm going to keep moving forward. All right, that's just a very quick run through. You can also constants, right? Multiply the constants through. So you have 1, 2, 3, 4, 5 rules. I think I went over like 4 of them. The constant one, the last one. It's pretty straightforward, right? It's really not that bad. So there's a whole bunch of notation in your notebook. Okay, I'm going to try and go over the. I'm going to try and go over the stuff that you really just should know the best. I am going to talk about. Cool. Let's talk about this one, okay? X squared minus 1 over x minus 1, okay? We're taking the limit as x approaches 1, okay? Not from the right or left, just as x approaches 1, okay? If you were to plug in 1, right, you could quickly see you're going to get 0 over 0. This is undefined. We have no idea what this is, all right? So let's see if we can reduce this down a little bit. Now, you're probably thinking back to the very first day when I gave you that horrible factoring assignment. Zach, why on earth did you give us a factoring assignment? We don't use factoring calculus. Aha, yes, we do. See this right here? This reduces to x plus 1 on the top, x plus 1 times x minus 1, right? Basic reverse FOIL method. Yeah, I understand. Factoring worksheet, way more complicated than that. The problems will get harder, I promise, whether that's a good thing or a bad thing. But obviously you can see we use factoring all the time, right? These cancel out, we're left with x plus 1, okay? The limit as x approaches 1, that is simply equal to 2, right? We plug in 1, 1 plus 1 is equal to 2. That is the limit as x approaches 1. Now we have to keep in mind, okay, when we graph this, okay, y equals x plus 1, we have a hole, right, at x equals 1, right? Kind of like I discussed earlier. Okay, that's how you start to solve these types of problems. Let's keep going here. Let's find another example. All right, we have 3 plus h squared. We have 3 plus h, I'm going to use capital H. We have 3 plus h squared minus 9 over h. All right. This should look strikingly familiar. Okay. Those problems that I had you doing where we were just plugging in those h's, right? Now you can see, right? In other words, you left it in terms of h, right? Now you can see we're canceling out those h's so that way we can find the limit, right? In this case, we're taking the limit as h approaches 0, right? So for those of you that were a little bit confused, now you can see where we were going with that in the past assignments, okay? First thing, let's factor this out. So we get, oh gosh, on the top, we get 9 plus 3h plus 3h. So that's plus 6h plus h squared, okay, minus 9 on the top. And then we have all over h, okay? The 9 and the minus 9 cancel out. We're left with 6h over, 6h plus h squared all over h, okay? Now you can see, oh, look at that, more factoring. We pull out an h, so we are left with a 1 on the bottom here, okay? We are left with a 6 plus h on the top. Hopefully everyone can see I just factored out an h like so. Sorry, an h over h, right? These cancel out. We are now left with 6 plus h, and we're taking the limit as h approaches 0, okay? So this goes to 0. This is also another notation, right? If I draw a line through something and I put a number, okay, I'm just saying as h goes to 0, okay? It's that similar notation. This is just 6. Hopefully everyone can see that, right? Pretty straightforward. Cool. 10:05, we're actually doing great on time. I'm doing great on time. You might be just like writing super fast and like not understanding it. I get it. It's okay. Go back, YouTube. It's there. Yeah. Also, okay, let's move on a little bit more. The squeeze theorem. I did not assign a homework problem on the squeeze theorem. That's because all the homework problems that involved the squeeze theorem were very time consuming. Is that a good thing or a bad thing? I don't know. I'm assigning you a total of 6 homework assignments or 6 homework problems, of which they should be pretty straightforward and easy for the most part. A little challenging, right? But no, the squeeze theorem, I want to talk about it conceptually. So just know when you get to Math 1A, all right, you're going to see the squeeze theorem. You're probably going to have some problems on it, but I'm just going to talk about it conceptually from this point. So that way you can kind of start to understand the squeeze theorem. So that way when you have to apply it and you learn it again, that's the really nice part, okay? Anything you don't understand now, you will learn again in your Math 1A class. Hopefully it will start to click once you get to Math 1A if this is your first time seeing it, right? And if this isn't your first time seeing calculus, that's even better because now you're just refreshing yourself to go in super strong, right? But the squeeze theorem is basically saying this. Let's say we have three graphs, three functions, right? The h of x, g of x, and f of x, okay? H of x looks something like this. Also, this is page 101 on the textbook if anyone would like to follow along, okay? We have h of x, it does something like that, all right? I don't know exactly what it is, okay? I don't know the graph, but h of x looks something like that, okay? We have the red graph now. The red graph, let's say it comes in from the top, right? It's doing something like this, and it does something like that, all right? Pretend that that touches, all right? And it does something like that, cool. And that, let's call this g of x. And let's call this last graph f of x, right? It's coming from down here, okay? And there it is. And there it goes. Right, there's f of x. Cool, like so. Pretend that all of these, like at this singular point right here, pretend that those are all touching each other, okay? What is this? What is this squeeze theorem? What is it saying? What does this all mean? Okay, we have three functions. As you can see how the green graph and the blue graph, you can see how they're kind of like squishing the red graph, right? Obviously, they all cross at the same exact point, right? So the limit as they approach that one singular point, they all squeeze together, right? So what is this telling us? The squeeze theorem is saying this: if f of x is less than or equal to g of x, okay? And g of x is less than or equal to h of x, okay? When x is near a, except when it is at a. So when x is near a, so as we're approaching a, right? The limit as x approaches a, okay? It's not a 9, it's an a. I'll try and write my a's a little bit clearer with like a little bit of a tail on them. The limit as x approaches a of f of x is equal to the limit of h of x, right? The limit of h of x. Sorry, let me get rid of that. As x approaches a, right? And we call that value L. A would be the dot, right? Yes, that's a really great question. This is the point A, right? So as x is approaching A. Thank you for that. Yeah, little things like that. If you're a little bit confused, let me know. I can add it in, right? Yeah, that is A. That is the point A, okay? So the limit as f of x as x approaches A equals the limit of h of x, right? So you can see how the green graph and the blue graph, right? Technically, I said just pretend that those are touching, right? I can only draw so precisely with my finger, but you can see they're getting squeezed together and they basically equal each other, right? And we call that value L, right? Where L is just a number, right? It could be 5, it could be 4. In this case, let's say it's +3, okay? That's a 3. All right, let's call it +3. So you can see they equal each other. Now, what does that tell us? That tells us by definition then that, oh gosh, okay, so that equals out. Remember that notation. I'm going to draw up here. That tells us then that the limit as x approaches a, right, for g of x, okay, of g of x, okay, that also equals L, okay? So this is the full definition, okay, of the squeeze theorem. Sorry, it's a little bit cramped, okay? So if f of x is less than or equal to g of x and is less than or equal to h of x, and f of x and h of x both approach L, that means that g of x also approaches L, okay? That is the squeeze theorem, okay? Remember this picture in your head, right? This graph and this graph, they're squeezing each other. By definition, that middle graph obviously gets squeezed in between them. Boom, they approach the same value of L. In this case, L is equal to 3. All right, it is 10:11. Look at that. Did we cover just about everything? I'm about to check and see. Problem 31, yeah, we did that. Number 1, even better, and number 13. We did it. I don't know how, but we made it work. You're all about to kill me. You're like, please stop talking. I can't take any more. I am done. Let's go over homework. How was that? How was that? Was everyone able to follow along, or did I just completely like go past everyone's heads? Thumbs up, thumbs down, thumbs in the middle. Come on, he's giving me a thumbs up. Cool. Everyone is so shocked that they're just not even typing in the chat. They don't know how to process it. They're like, Zach, you talk way too fast. I know. But that's okay, because when the improv workshops come up, I'm going to be talking even more. Okay, homework assignments. I can tell. All right. Let's go to 2.2 real quick. No, but seriously, though, is everyone okay? Right? Just let me know in the chat. Are you good? Everyone good? No one in the chat. Good. All right. Jasmine says good. Sebastian, cool. Jose, Allison. Okay, cool. Okay. That makes me feel a little better. I was getting a little worried there. Okay, we'll review it. Yeah. And is exhausted from the note taking. Yeah, I know, guys. I'm sorry. I know it's fast paced. I'm really trying to be as clear and concise as possible, but also at the same time, you know, get you up to speed. But I really appreciate that feedback. I really do. And I will try my best to not be overly crazy and fast. Okay, 2.2, let's do numbers 4. Numbers, I had another one for you. Number 4 and number 32 and number 41. Okay, so 3 problems from 2.2. Now I'm going over to 2.3. 2.3. Could you imagine trying to do the entire math course in 3 weeks? Because that's what prep originally was for some of the courses, right? We were going over the entire class in 3 weeks. It was insane. So we're only trying to get through half. But yeah, there's a lot of stuff and limits, but it gets easier after this. Okay, 2.3, numbers 1. Okay, try number 13 and try number 31. All right, so 6 problems. They should be straightforward. Do what you can. If you can't do everything, that's okay. Other than that, it is 10:14. We finished 1 minute early. That is awesome. Thank you so much for all of you who stayed and participated. Number 1, I love to see the participation. That's really awesome. Number 2, thank you for working hard. I know you're all working hard, especially on the homework. Number 3, just, I mean, yeah, keep putting in that work. It will pay off, right? The one thing I always like to say, right? Work hard now so you don't have to later, right? That is essentially the goal of prep, is to work hard now in these first 3 weeks before school even starts. So that way you're 3 weeks ahead, more like a month ahead, a month and a half. You are a month and a half ahead of all the other incoming freshmen, right? So again, thank you so much. I'm sorry for going fast. I'm going to get these videos uploaded to YouTube. Other than that, any questions for me? I'll be here for a few minutes. You're good to go. I look forward to everyone in the improv classes in the coming few days. It's going to be a blast. I'm telling you, it's going to be a nice break from all of the stuff that we've been doing. So on that, yeah, I'm good to go. You guys are good to go. Check the website, check the YouTube channel, and I will have the uploaded. Jasmine, see you later. David, have a good one. Annie, have a good one. Thank you. Yeah, see you tomorrow. Ricardo, Felipe, have a good one. Yes, Brianna, Juliana, Stephanie, Angelica, thank you. Do you know of any good resources to learn trig basics and the unit circle? Yes. Okay, so stay real quick, and we could talk about it. Allison, have a good one. Sebastian, have a good one. Hector, have a good day. I'm going to try and respond to everybody. Cool. Yeah. All right. Yes, Emmanuel, have a good one. Thank you so much. All right, and I'm going to stop the recording there.